the very first library, which is NumPy, which is it stands for Numerical Python, Numerical Python library. So if you and again the libraries that we are going to discuss today is NumPy, Pandas, and Matplotlib. So numerical Python is because if you want to do any numerical calculations that involves mathematical standard equations or mathematical functions that you want to do, instead of you writing it from the scratch in Python, the community, the library had already taken care of building arrays for you and building those mathematical functions for you and made your life easy. So you just import it and then use it as per your name. That is with the numerical Python. The next one is Pandas, which stands for Python panel data sets. So they are the library. Pandas is almost everything that we deal with the tables. So with the data frames and series and arrays. So from Pandas library, we can import any CSV files or Excel sheets and do any data analysis on top of that also, if you can learn this. And on top of that, these pandas are going to be useful for you to play with electrical table sets as well. So that's going to be a very important library. And then third one is Matplotlib to do any part of visualization on top of uh, any library. It can be NumPy or Pandas. If you want to do visualize it in terms of graphs, mathematical graphs, it can be a bar chart, pie chart, or a scatter graph, and or a linear regression graph. So we can plot those graphs using Matplotlib library. And there are other libraries like Seaborn Lab and Plotly libraries. You can also learn. You can also adapt learning those things. But again, these are the minimum basic requirements that we need to have before we move on to the next day 4 or day 5. So I hope these three libraries will be completely hands on for you, and I will request you to simultaneously do if possible. But I'm right now sharing the link of today's collab file in the Google chat, so please try to access it. You can just refresh my page, it will directly be available for you. So I'm pasting it in the Google chat. So yeah, we'll get started with numerical Python. So the NumPy, always you can see that it stands for numerical Python. So if you ask me a question, the new NumPy library almost revolves around the arrays, which is nothing but list. So if you remember, we discussed data type list in Python programming, where a list is nothing but a collection of items or collection of elements, collection of multiple values in one square bracket representation is what we learned, right? So similarly, I even told that there is something called an array, which is not completely same as an array in other languages, but there is a difference in Python. That exact difference is what we are going to discuss today. So array in Python is coming under NumPy library. List in Python is just a data type in it. So array in other languages is a different different uh, actions altogether. So I suggest you to never compare arrays in other languages to the Python array or Python list. There are differences. So now moving on, uh, if you ask me why array concept when you already have list, what are the differences to the existing list concept in Python and array concept in NumPy is, if you remember when I told about the list, I hope you can see the Jamboard as well. So if you see a list consists of multiple numbers like this, 1, 2, or and so on. If these are the items or elements of a list, so usually list saves these items one after another in adjacent memory locations. That is the very first factor. Second factor is you can use any data type as an item inside this list. You can either write a number, or you can write a string, or you can write a complex number, or you can write a sub list, or you can write a tuple, or you can write a dictionary, or you can write a set. So any item is allowed to be an item inside a list. But when it comes to array, it can only have homogeneous data type. It means the data type of the item or the element that you are going to assign in this array should be unique, unlike the list. So, and the data structures, it means internally array uses linked list and other data structure concepts to make this more efficient and easily accessible compared to the list concept in the Python. So these are going to be your key differences. I'm going to show you the example of a list and then array and what are the differences in the Google Colab. But yeah, this is going to be the key differences. So if you see here, if I just take a list like this and confirm that it is a list. So I hope you already know how do we confirm the data type of this. It is type of A. It's a list. How do we create an array in Python? That is where we will be using, by default, NumPy array is not going to be in your kernel, in this case in your IDE. So if you want to use it, you have to enable it or you have to import it. So the syntax to import something, any library, is the keyword import, and then you have to specify the library that you are trying to import. So NumPy is a library that I'm trying to import, and then as stands to the alias. It means whenever I want to use the library NumPy, I don't need to call the word NumPy. Instead, I can keep an alternative, something called NP. So NP is just like a shortcut form to the NumPy. So whenever I say NP, it's nothing but it is referring back to the NumPy. So we will be importing NumPy here. So now it will allow us to use this NP keyword as an importing library anywhere when you apply in this throughout this collab notebook. So now let me try to create an array for you. So the way to create an array is np dot a method array, and here is what you can give the input. In my case, let me give the same thing. Whenever you get these suggestions, I said you can press escape key. It will avoid that auto suggestion. So now let us try to run this. So array of 1 comma 2. So this is a list and this is a NumPy array. So the difference again, right now, if you see my data types of the items is just a number here, and here also it's a number here. And if I try to keep a string in this, let's say hi here, and then let's try to give a sub list in this 1 comma 2, something like this, and let's try to run this. So let me also print the list along with my type. So I can do print a type of A. So A is nothing but this, and the data type belongs to the list, which is a class. So you don't need to worry about class right now. This is a oops concept. It is just trying to be accurate to show you that the data type belongs to this class. So don't mind about this class. It is nothing but being accurate with respect to data structure, oops level. All right, so now np.array is this. So what is the confirmation? Again, if you see, if I include a string in this, let's say some 45 is a string again, and let me give another string, something like this, and try to array. So you see this, even though I gave numeric data types as an element here, still it gave me an input as a string. So it automatically converted my numeric data type element to the string. Why is it happening so? So in the concepts of higher order data types and lower order data types, the integer, the float, and then the complex, and then the string, this is the order that we have to follow in terms of the lower order to higher order. So the higher data types, data types are strings, again, list, tuple, all those going to be coming under sequence data type. But if anybody asks you any sequential order when it comes to data types, so the integer comes the very first preference, and then next preference goes to float, and then goes to strings. Right now the higher data type is string. So even if one element is of string data type in this entire array, it will convert entire elements to string. So if you want to see that again, so let's only take a simple numbers like this. So right now, all my data types of the items that I use in this array are numbers. So it's going to be just a number. And if I want to use a string in top of this, let's say if I even convert one element to string, it will convert all of that to string. So instead of string, let's say I give a float value. When it comes to 44.5, it's a float, right? So if I run this, you see that it converts even the integer data type to float. So here float is going to be the higher data type compared to a simple integer. So 1 and 2 are integers. As there is a float value as an item in this entire array, it converted even previous ones to float. So that's how differently it is with respect to the list. So this confirms that the NumPy array is a homogeneous, not heterogeneous. So lists are heterogeneous data type items allowed. This is a homogeneous data type items allowed. That is with NumPy array. And moving on, what else we can do with NumPy array? We can store this NumPy array in some variable, which is like this. Let's say I give A and B and C and D. This is one of my examples to array. Let me try to print it. Good practice is to use print function. It printed my NumPy array. Again, what is the confirmation that it is an array? You can see that the type of A here is going to be the type of A is going to be the NumPy n-dimensional array. So the difference again for the list is it's a list. For NumPy array, it is going to show you NumPy n-dimensional array. So whenever I'm using this dot, it means from the NumPy library, I am making use of array function or a method, right? So now it says that there is something called n-dimensional array. ND stands for n, D stands for dimensional. So n-dimensional array. It means that there are dimensions involved within this array, right? So 0 dimensions is obviously, you must be aware that it's a scalar, right? So 0 dimensions is a scalar value mathematically speaking. Again, whenever people say scalar, you must be aware that it's just a value magnitude without any direction, which consists of only magnitude. So the one dimension thing is nothing but a vector, which is nothing but represented using array in our case. So arrays are going to be our vectors, which consists of magnitude and direction. You can apply matrices, or you can apply vector algebra kind of calculations, mathematical calculations, or you can apply linear algebra calculations using these kind of array representations. All right. So now 2-dimension is a matrix. A matrix is nothing but a combination of multiple arrays, which is a 2-dimension, right? So combination of multiple arrays, and the 3-dimension or more belongs to tensor. This is where you can see that it is going and relating to the machine learning libraries there, which is a famous library out there is a TensorFlow, which is again on top of multiple dimensional arrays like this. So TensorFlow literally works on these things. Anyways, the concept is about NumPy, so let's stick back to it. So now that we know which dimension is which, I've been defining the simple array that is 1-dimensional array. So 0 dimension is nothing but a simple integer, and this array is nothing but my vector. This is the way we can represent a vector. If I want to create a matrix, you just give multiple of these arrays, it becomes a matrix. So before we go on to matrices or seeing those multiple things, let me also show you multiple ways of defining an array, just not like this. So for example, I have a list like this. Let's say I have 5, 6, 7, 8. So this is a list, and I want to convert this list input to an array. So what I would like to do is np dot array of a. So all the values that are there inside a will become type converted to array. So this is how the array becomes. This is one way of defining an array, and another way of doing it is you having a range function. np.array is one function, so you also have a range function which will allow you to give a range to this. Again, dating back or tracing back to our first concept in slicing or indexing in the data types of Python, it also follows the same as range function. The syntax for this is going to be start value, stop value, and step value. So it remains same here as well. If you had learnt it once there, the same concept will be applied throughout this libraries and all over the Python. So in my case, I would like to generate an array which starts from 1 and ends at 10. As you remember, 10 is usually considered as excluded part, right? So let us see now. So it generated an array from 1 till 9 excluding 10, because the second parameter is standing for end value, and as you remember, end value will always be excluded. So now let's say I would like to create another array, np dot range of let's say 1 to 50 with a step value of 2. You do see that it generated an array of elements from 1 to 50 excluded, which is like till 49 with the step value of 2. It means it starts from 1 and 1 plus 2 is always a 3. And then 3 plus 2, 5 plus 2, 7 plus 2, 9, and so on till the range that you specified in the end, which is exclude. So this is how you can generate an immediate array if you have this logic enabled. So that's how you can do with a range function. Or similarly, if you want to build a matrix of this, let me take this function and put it in a variable. As I said, a matrix is nothing but a two-dimensional thing. So one square bracket in a shortcut way, this is just like a mind mapping. If you have one square bracket, it means just single array. It means a vector. So if I have to build a matrix on top of this, let me take an arrange function to build an array and put it in a variable like this. Let me confirm what it is typing. So it is going to generate an array from 1 to 9 excluding 10. Similarly, I'll create one more array, np.arrange of, this time let's build from 11 to 20, and let us also confirm the existence of b. So it generates from 11 to 19. Now that we got two different arrays, I would like to build a matrix on top of this. As I said, a matrix is nothing but a two-dimensional thing. So matrix will have two dimensions, in two different inputs. So now let me keep this a and b as an items to one single array. So whenever I say an array, we will keep one square bracket which represents a one dimension. Internal to this, we will give values a comma b, and let us try to see this representation. Yes, this is how it looks like. So now it means it is a two-dimensional array, which means this is a matrix. In generally, we will represent a matrix to the students or outside with a longer bracket like this, and we represent a matrix like this. In Python programming and while typing it, we will be representing with the square brackets in this way. All right, so that is how you can also generate a matrix. A matrix, again, you can have any number of shape. Usually matrix is considering a considerable number of rows and considerable number of columns, right? So if you want to check the size, even that is also possible in here. So in order to check that, you can just check size here. So in my case, this is the matrix. So let me name this matrix as C. So C becomes my matrix. Let me type C and then confirm again. Using A and B values, A and B arrays, I built a matrix. Now C is this. Let me apply something called size on top of my C. You do see that there are 18 elements. If you want to confirm it, let me put this in a different cell and see the differences. Let me print C here. Let us see the size of the matrix. This is 18. So why is it 18? You can see that it is 1 to 9 and 9 to 2, it is 18. So these are any number of elements. And if you want to see C dot n dimension, it is telling you that this array C, this variable C consists of a two-dimensional matrix. So it is a two-dimension. This is how you can check any in which dimension that particular array or that particular variable is having. All right, so this is one way, and you can also see the order of the matrix with C dot shape. which will let you know that there are 2 rows and 9 columns. So this is a function where it will be used to see the shape of the matrix. And again, you do know that there are transposes and there are a lot of matrix calculations that we can apply. All those can be applied in this numerical Python as well. So in my case, if you observe, there are 2 rows and 9 columns, which makes that 2 into 9 is nothing but 18 elements. What are the shapes that I can also try with respect to 18 elements? If you see, what are the other shapes or other dimensions that I can try with 18 elements? So 2 comma 9 is like 2 rows and 9 columns. Obviously, it makes up to 18. So it's just like we are finding out other shape is nothing but other factors of 18. So what are the factors that it can be? 2 into 9 is already done. So it can be a 2 by 9 matrix, or it can be a 3 into 6 matrix, which makes it 18 again, or it can be a 6 by 3 matrix, which makes it 18 again, or it can be a 9 by 2 matrix, which means 9 rows 2 columns, or it can be a 18 by 1 matrix. So these are the possibilities of these matrices. If you want to cross check it, you can try on one matrix like this: C dot reshape. Currently my C shape is looking like 2 by 9, so let me convert that to 3 by 6. So let me reshape it with 3 comma 6 and try this. You do see here, before shaping it out, it was 2 by 9 like this, and it became 3 by 6 like this. It means 3 rows and 6 columns. So this is how you can reshape your columns as well. All right, so that is your n dimension thing. Or now that you are a 3-dimensional matrix, I want to bring this to back to 1-dimensional array. So that is exactly where you can apply. Now let me store this array in one variable, let's say d in this case, and run this. So d is my variable like this, and I would like to, let's say, I would like to bring this back to my 1 dimension. You can apply a direct function called flatten, which will bring back your 2-dimensional vector to a single dimensional array. 2-dimensional matrix. I apologize for the vector. This is 3 by 6 matrix, which is a 2-dimension. How did you say it's a 2-dimension? This is the shortcut you can remember, or you can apply dot endem function on top of it. So in this case, reshape did me 3 rows and 6 columns, and I used flatten on top of it, which reduced it to a single dimension. You see that there is a single bracket. This is how you reduce from one dimension to another dimensions. All right, so again, what are the other ways of shortcut ways of generating arrays? So Python, numerical Python provides you numerous functions in that way. So you can try np dot once. If you specify a number like this, np is again the shortcut that we all agreed upon while importing the NumPy library. See, this is why I'm not writing NumPy all the time, and I'm applying once function on top of NumPy library. So what I'm saying with this function is, I'm asking my NumPy library to generate 6 ones as an array. So it generates an element, 6-element array. If I want 10 elements, it will give me 10 elements in one array. So it is just one dot means it's just trying to be accurate in float values. So this is how you can generate ones, or simultaneously you can generate multiple dimensions with only having ones. Again, once in a matrix, all the elements as one is nothing but a unit matrix. So in my case, let me try to generate a 3 by 3 matrix. Let's give one more function input. So it generates 3 rows and 3 columns, one all our numbers as ones, because the method that I'm applying is ones. Simultaneously, you also have zeros as a function, which will reduce your burden. So it will generate an array of all as zeros, and simultaneously you can generate a null matrix with zeros. So not just zeros and ones. Now that you got it out, can we only do ones and zeros? Can we not do other numbers? You can also do it with full function, which will allow you to keep any customized number that you want to do with respect to matrix. So in your case, you can fill the number, let's say 3 for 3 times. So it will generate number 3 with 3 elements in that array. Let's say you want number 3, let's say 10. what it does is three tens. So if you want a number, let's say seven tens, will give you a array which has seven tens in this. So this is how you can do. Also apply dot full. You can generate, let's say, 8, comma 8. Will just give you 8 eights. So this is a shortcut way of doing uh, customize the generation of the inputs. All right. So on top of this, you must also know about the slicing concepts. Again, the slicing in NumPy array is not so different to the slicing concept which is in Python. It is absolutely the same. This is exactly why I said if you learn it once, it is applied on all over the Python program. So let me try to take an example. In this case, let me take this. I'm making use of this concept. Let me apply this. If you see here, my matrix looks like this. In this, I would like to access only, let's say I only want to access 1 to 11 12, not all the elements, just 1 2 and 11 12. So the syntax for slicing is, again, you can use np dot array. In this case, you already have that created, so you can just say, see, if I print, see, it is giving me this. If you apply the slicing on top of it, let's put like this and run it. So you do understand that I did not mention when to start and I did not mention when to stop. It means to find those accounts. Yeah, it means you are not saying it when to start and when to stop. So it is by default taking all of them as, for the consideration. Let's say you have a considerable, let's say, a condition like this and run it. So what it will do is, let me even give 7 to 7 and 1 colon 2. Okay. This is for rows and this is for columns. Let me just say till fourth column. So what you see in this is the very first syntax is for the rows. So maybe if you want it as a general syntax, let me write it on top of it. It will be easier for you. So this is like start row colon and you can say end row for rows, comma, and the start column colon end column. And you can also write step here, so which we will avoid it right now. Reduce the complexity. So if you see here, I left this empty. When it comes to rows, it means I'm literally asking it to print all the rows available. But here I am telling nothing in the start column. It means starts from very first column itself. If you leave it nothing, if you leave it with nothing, it will just start from by default the very starting one. Fourth means it will go up to fourth column. So if you see here, 1 2 3 4, it's the fourth column. If you want specially let's say second column to fourth column, this is how you can access. If you see here, it is, again, why it is going from 2, you remember the indexing concept. This is 0th column, first column and second column. So this is exactly why 2 colon 4 means it is taking from 3 and then this is 3. If you remember, 0 1 2 3 4, 4 always is an end value. End value is always excluded. That is exactly why it is starting from second index position, goes till third column, because fourth column is an end value and it always excludes the end column or end values. So this is how you can access a sub part of one matrix. All right, so you can now play with, you create your own matrices and you can play with these positions. You can try to access any part of this. That is how accessing sub part of the matrices happen. And if you want to generate a line space, there is a line space for it. What does it mean? Let's say I want to generate equidistant points from 1 to 10. Let us see, run this right now. If you see here, it is trying to give me a minimum, which is a default value. It is trying to give me 50 equidistant values ranging from 1 to 10. These are equidistant values from 1 to 10. It means I did not specify how many points I want here, so it is by default giving me 50. What if I give 5 points? What does this mean? I want a range from between 1 to 10, 5 equidistant points. So let us see what does it generate for us. If you observe carefully, from 1 to 10, 1 to 3.25, then 5.5, 7.75, and then 10. These are the equidistant points. So if you see this, the difference between this point to this point and this point will be same. And then this point to this point. So these are the equidistant points from one another. Let's say I want to generate line space. Let's imagine I want to generate, let's say from 10 to 20, 3 points, which are equidistant to each other. It starts from 10 and then 20. So it asked 3 point. We asked three equidistant points ranging from 10 to 20. So 10, 15, 20 are the three equidistant points, right? 10 to 15 is 5, 20, 15 is 5. So these are the three equidistant points. This is how you can generate a line space arrays with equidistant points. This will be very much useful in comes to electricals when you want to generate line spaces. So that is this. And I think there are other functions, mathematical functions like square root and sort, all of that. They are very simple for you. I think it's like if you have an array like this. Let me take an example of this. I don't want a range. Let me take an array and write 1, 3, 5, 8, 9, randomly some numbers. So this is an example of an array. Now what I would like to do is, let us try to apply few mathematical arithmetic operations on top of these arrays. So if this is my A array, and if I do let's say square root on top of this, sqrt is a function for the square root in regular way. So if you run this, it will show you a value after applying square root on top of each and every element of it. So square root of 1 and square root of 3, square root of 5, square root of 8. If you just mention single variable like this, it will apply on each and every element of that array. So this is how the square root function works on it. Or if you write a plus a, so I'm just moving to arithmetic operations. Let us see what does it give. So if you remember, if you observe it carefully here, it added array to another array. In this case, I'm adding two same arrays. So 1 plus 1 is 2, 3 plus 3 is 6, 5 plus 5 is 10, 8 plus 8 is 16, and so on. This is how arithmetic operations will be applied on top of each and every element of that array. So you don't need to specifically tell for each and every element like this. Just apply this. By default, it will take on each and every element. So that's one way of applying functions on it. Again, if you want to do some, let's say, comparison operations, let me take the same example of array. What I'm going to do is, I would like to access elements which are greater than 10 from this array. I only want elements which are greater than 10. So if you do a greater than 10, by the logic of previous one, if you remember, when I did square root, it applied on each and every element. When I did this, it added element wise addition. So this element position to this element. Right now I added to itself. So the dimension and the length of the array remained the same, and it added element to element. If you give a different length of the array, it will not do that element wise addition. What I mean to say is, if my A is this and B is having something like this, I cannot add A array to B array. It is because the dimension, not just dimension, the length of this array is different to this, and there will be incompatibility. So you can never apply element wise things with incompatibilities. So now similarly, when I apply a greater than 10, it will try to go and compare each and every element of this array and see what does it give. See there, it is giving you the Boolean outputs after applying this condition on top of comparing with each and every element of that array. So whenever it is true, it is giving us true. Whenever it is false, it is giving us false. So now what I'm going to apply is, on top of this logic, I want elements only when there is true function. I mean, not function, a true Boolean case. So what I will do is a of the condition that I want to apply is a greater than 10. You see, the only values which are greater than 10 will be considered and will give you an apply. This is how you can apply any condition or an expression on top of an array. Like this, you can apply less than, you can apply greater than, you can apply comparison operator, double equality, or you can apply a expression on top of this. So everything will be just within the square brackets. So it is the reason, again, if you want to understand more syntactically, you remember when I just gave 10, it was giving me Boolean outputs. So this syntax will literally apply the output of this expression on top of each and element. Whenever that condition becomes true, then only it is displaying the output. So that is the internal understanding of how this mechanism works behind the screens. Nevertheless, we'll move on to the only relevant ones to our electricals. Let's apply say statistical terms as well. Statistical methods. If I take this array itself as an example, you can apply mean, mode, median, and all of standard deviation, variance, all those things on top of this right away. So if you see here, let me try applying a dot min. So in this array, the minimum element is 1. So let me try applying max. It's very straightforward. It is the maximum number in this array. And let me try applying mean on top of it. So the mean value on top of all the elements of this array is 14.65. Again, you already know that how do we calculate mean? Sum of all these elements divided by total number of elements. So that's how you can apply. There are functions for each and everything. And if you want to get a look at list of functions available, as I always suggest, please go for W3 Schools, NumPy, Python NumPy. Very good resources with all the list of available functions. You do see that there are these many statistical, usually we use this for during our day-to-day life in machine learning model trainings, but for you, I don't think you will be needing this much trigonometric depth functions, but it is very easy to adapt. In my case, let us say I would like to do some NumPy functions on simple arithmetic. So you do see that np.add, np.subtract, and rounding of decimals or summations, truncating, fixing it, rounding it off to the previous integer, rounding it off to the next integer. So all that we need a takeaway from this session is it is not a difficult thing to adapt to these functions, and nobody asks you to remember all of these functions. It's just that if you know the syntax of how an array is built and how do we define a variable and how do we apply a function, you can just right away Google function name, what is the thing that you want to do. Now that it's a chat GPT era, so nobody cares whether you are reading it from the scratch or from the right away. So you just need to know when to apply what function, and if you have that smartness, NumPy is something not you can remember all the things that it exists. You just need to know the application of it. So that's how we do statistical on top of it. And yeah, there is standard deviation as well. Again, NumPy, no, yeah, great. Standard deviation. So this is the standard deviation value of that. If you see here, I have an array which consists of strings, and I have another array which I am trying to generate random numbers which are going to be 7. So if you want to see the output of this, so what it is doing is random is a method module within the NumPy library. So random is going to generate random numbers which are 7 rows and 4 columns. If you see here, there are 7 rows and 4 columns. So if it is of 2 dimension, obviously it's a matrix, right? So you can see that it's a matrix. So the easiest way of generating array. So random is a method, again module, in which it is using rand_n method. So in this case, it is generating 7 rows and 4 columns. So if you see here, I have 7 names and I have 7 by 4 matrix. You can literally compare it like a table or a Google sheet or an Excel sheet. There are seven. This is like heading of the table which we have underscores. So for these many friends, these are the scores. So I'm trying to relate these two arrays right now. So what I want to do on top of this is just like a simple example analysis. What I want to do is I want to have only scores of, let's say, Bill. I want only the scores of Bill. So what I can do in this case is, if I try to compare it, there are seven names and there are seven arrays here. It means Tom row is this, Joy row is this, Bill is this. So for every name that we have in friends, there is one array row dedicated for it. So these are the scores of that particular person. Now what I'm asking you guys is, can you guys give me only the scores of Mr. Bill? So if you compare the positions here, the Bill scores are going to be somewhere this, right? This is the third name and this is the third row. How do I write a logic in such a way? I would like to access only Bill's scores. So that is exactly where we can use the syntax of how we applied this one. The same syntax as this. So what we will do is, I am expecting the scores of whenever the scores are equal to the Bill. So in my case, friend must be Bill, scores of Bill. So what I'll do is, friends is the array name that I dedicated is equals to Tom, sorry, Bill in this case. Let me run this. I forgot to run this. You do see this? It is saying 0.78, and let me also run this guy. And let me run this guy. Yeah, you do see this. Bill is in third position. This is the row, and it gave us immediately that row. So it is comparing the scores column whenever friend is equals to Bill. So this is how you can apply conditions on top of another array. So again, these kind of concepts are more in data analysis levels, but for you to have an understanding in hands-on, this is how you can apply. So can you guys now tell what if I want to only access first two values? If you remember slicing concept, if I want to only access only first two values, what if I want to access only first two values? You do remember that this is a matrix because it's a two-dimensional array, and I'm trying to only access first two values. So if you remember my slicing concept, you need to give colon syntax for rows and then colon for columns. So how many rows in this case? Obviously one row here. And how many columns that I'm expecting is two columns. So all that you need to do is, this is how the slicing concept works, right? So on top of this, all the rows, in my case just one row, and I'm only expecting till second column. Starting is from the 0. So this is how you can access. Let me keep both of them for you. So this is the original one. What I did is I just applied all the rows, but starting from 0th column till second column. In this case, this is 0th column, first column, and second column. As you remember, second is nothing but an end value. End value gets always excluded, so it accesses it from 0 to 1. So this is how you can access slicing on top of arrays. So this is how you can apply on functions. Again, what if I want to access values which are only positive? One last question on this so that we can move on to next library. So can you tell me a logic where I can access only positive values out of this matrix? So how do we do that? Only positive values out of all of this matrix. If I right now do for scores, is displaying all the values. But if I'm expecting only positive values, you do remember whenever I want to apply a condition, start the square brackets and then go for the condition that you want to apply. As I'm expecting only positive, the mathematical logic behind that seems is greater than 0. So when we run this, you get a list of array of elements which are all positive from this scores. If you want negative, go for less than 0. If you have a specific condition, you need to write that condition here. This is how you apply conditions on top of arrays. So that must be good enough for you to understand the NumPy. Yeah, that's all about numerical Python and arrays, guys. So this must be good enough for you to understand what is an array and how do we apply NumPy things on top of electricals.